Hello students and viewers at home. My name is Dr. Mrs. Augustina Ezeama from Mathematics Department, St. Charles College, Onitsha. You're all welcomed to today's online teaching. I am going to take you on mathematics of SS classes, precisely SS1. The topic is mensuration, specifically length of an arc, perimeter, and the area of a sector of a circle. Let us look at the specific objective of this lesson. By the end of the lesson, you should be able to give the meaning of mensuration, identify arcs, segments, and sector of a circle. Then you solve problems involving length of an arc, perimeter, and sector of a circle. Let us look at the procedure. Mensuration is the act or process of measuring measurement. But in mathematics, mensuration is the study of measurement, especially the derivation and the use of algebraic formulae to measure the areas, volumes, and different parameters of geometric figures. We are going to look at that geometric figures. If you look at the circle here, the first circle there, we have major sector. And the sector below it is the minor sector. The line under the minor sector is an arc. And that line from the center of the circle is a radius. This is in the case of major sector and the minor sector. The second geometry there is major segment. If you look at the minor segment, there is a line above the minor segment. That line is called a chord. We are going to look at how we apply them in mathematics. Let us look at the formula for finding length of an arc, perimeter of a sector, and the area of a sector. You know, in formula, we have plural of formula, and that plural of formula is a formulae. We don't say formulas, but we say formulae. So because there are three here that are in plural form. So the length of an arc of a circle is theta over 360 times 2 pi r. And remember that the circumference of a circle, what's the formula? 2 pi r. So you will be remembering this by multiplying theta over 360 with that of a perimeter of a circumference. That is perimeter of a circle. So that is why we say that the length of an arc of a circle is theta over 360 times 2 pi r. Then let us look at the perimeter of a sector. Perimeter. That sector drawn, the perimeter is 2 radius, 2r plus length of an arc. And you know that any line from the center of the circle is the radius. So that 2 of that radius plus length of an arc below it from the diagram there, length of an arc. So that 2r plus theta over 360 times 2 pi r. That is the formula for finding length of a sector, perimeter of a sector, sorry. We are talking about, we have set of we have talked something about length of an arc. This one is perimeter of a sector. Now let us look at the area of a sector. In the case of area of a sector, you see that once you talk of area, you talk of circle of a circle, pi r square. That theta over 360, now instead of multiplying with 2 pi r like that of length of an arc, you go to pi r square because you are talking about area. So the area of a sector is equals to theta over 360 times pi r square. We are now going to the examples on this formulae I have talked about. 1. Calculate correct to 3 significant figures the length of an arc which sustains an angle of 70 degrees at the center of the circle. Take pi 22 over 7. In this case, before you solve the solution, you have 2 options there. You can draw a circle and show this 70 where it's supposed to appear. Or you go over to length of an arc given there, that of the formula I have explained before. Length of an arc, because you are asked to correct to 3 significant figures. So after getting the answer now, we are going to apply our knowledge. That knowledge you have when you solve in junior class significant figure is what we are going to apply after solving this problem. Length of an arc is equal to theta over 360 times 2 pi r. Substituting for the various values, length of an arc is equal to 70 over 360 times 2 times 22 over 7 times 4. And this gives us 2 times 22 times 4 all over 36, because that 70 there, you cancel 0, and that's 0 on 360. That you have just divided by 10, and the 0 has gone out from 7, and 0 has gone out from 360. And now we have 2 times 22 times 4 all over 360. And when you multiply out, you get 4.8889 cm. Remember, you divide into 36. So you multiply out the product of 2 and the 22 and the 4. You divide everything you got with a 36. So after dividing with 36, you get 4.8889 cm. Now you bring out the idea of significant figure. Significant figure, remember, you are going to start counting from 4. And you count out 3. 4 is 1, 8. Now 8. You know, 3 significant figure. When you count, after counting 8, there are 8 remaining. 8, 9. That 8 is above 5. Any number above 5, you can convert it and call it 1, and add it to the number following it. Now that is why we add 1 to 8. That is why our answer now is 4.89 cm to 3 significant figure. We go over the example on perimeter of a sector. Perimeter of a sector, that is distance round of a sector. Remember, the distance round, you now run, after running that of radius, the first radius, the second radius, then the arc. That is the area. The example here said the angle of a sector of a circle of radius of 10.5 is 120 degrees. Find the perimeter of the sector. Take pi equals to 22 over 7. Now the solution is perimeter of a sector. You quote that formula I gave you before. 2 times radius plus length of an arc. And you know that the length of an arc is theta over 360 times 2 pi r. In this case, we have 2r plus theta over 360 times 2 pi r. Now, we begin to substitute. That r is 10.5. Then theta is 120 all over 360 now. Then that 2 is there. Formula for 2r. You know we have 2 radius there in the arc. Then 2 times the r there is 10.5. Then the pi there is 22 as given in the question, taking pi equals to 22 over 7. That is, now we have 2 times 22 over 7 times 10.5. When you use 2 to multiply 10.5, you get 21. Then the other one is 22. And when you add 21 plus 22, you got 43 cm. Cm is the unit. Remember, if you don't write unit, you are wrong. Let us look at an example on area of a sector. Remember, there is pure difference between area of a sector and that of perimeter of a sector. In this case, the difference there is that you are going to use area of a circle to multiply theta over 360. Now, look at the example. The angle of a sector of a circle of diameter, ACM, is 135 degrees. Find the area of the sector. In this case, you are going to first of all apply the knowledge of diameter and the radius. What is the relationship? Because the formula here says area of a sector is equal to theta over 360 times pi r squared. But now, there is no r in the question. What do? We first of all divide the diameter by 2. Then what is the value for diameter? Diameter is 8. Now, you use 2 to divide 8. When you do this, what do you have? 4 cm. Now, let us go to the solution. Area of a sector of a circle is equal to theta over 360 times pi r squared. Here, radius is equal to diameter over 2, which is 8 over 2. And this 8 over 2 gives us 4 cm. You now substitute. In that very area of a sector, you go there. In place of theta, you put 135 degrees all over 360. Then you get that pi, which is what? 22 over 7. You write it 22 over 7. Then pi r squared is 4 square, which you can write as 4 times 4. So when you multiply out, you get 132 all over 7. If you divide 132 by 7, you get 18 whole number 6 over 7 cm squared. Remember, this unit is very, very important. In a final exam, if you don't put unit, they used to tell us to mark the person wrong. No, nothing like giving you 1 mark or half mark there. So it is very, very important. That is why we have cm square for area. Ordinary length is now cm only in the case of centimeter. Now, let us look at the various evaluation. Remember that the evaluation, you got it from specific objective, of which if the evaluation did not tally with that of specific evaluation or specific objective, you know that the lesson is not correct. But now let us look at the evaluation to see whether it tallies with that of specific objectives. In the first instance, I told you that you will be able to say the meaning or give the meaning of mensuration. Now we are asked here, define mensuration. Then here you will now draw and identify an arc, sector, and segment of a circle. After drawing and identifying the sector, the length of the arc, the sector, and segment of a circle, you will now begin to solve problems involving length of an arc, segment of a sector, area of a sector, and area of a segment. Now, the third one is solve the following. 1. A sector of a circle of radius 7 cm has an area of 44 cm squared. Calculate the angle of the sector correct to the nearest degree. Remember, the other one we said cm. This one will be to the nearest degree. How do you do this? You will now consult how you talk about nearest in tens, hundreds, and thousands. That is how we are going to solve this particular problem here. The next one is the angle of a sector of a circle is 105 degrees and the radius is 12 cm. Find the perimeter of the sector. Take pi to be equal to 22 over 7. In everything, you try to apply this, taking pi to be 22 over 7. If you don't do that, you now can make mistake because nobody knows the value, the meaning of that pi if you didn't write it 22 over 7. Number 3, the length of an arc of a circle of radius 7 cm is 14 cm. Length of an arc now. Find the angle on the sector of the circle. Taking pi equals to 22 over 7. After copying that assignment, solving it very well, accurately, with very good handwriting. What I used to see the way you pass the other one, I'm not impressed too. So in this case, whoever will solve it will use very good handwriting. Then you pass it, submit it to me through my WhatsApp contact 080-608-71316. I repeat, 080-608-71316. Thank you and God bless you for listening and viewing.